Hello everyone, this is Mr. Smith. Thanks for joining me, talking some chemistry. We're going to tie in the last couple of units, which was electrons and the periodic table, and connect it to the next unit, which is bonding. So just a few slides here. First one is this one, valence electrons. These are the electrons on the outside. When I say outside, I mean the last energy level. Here you have your main group elements, the first two columns of the periodic table and the last 6 columns of the periodic table. In the periodic table unit, we talked about all kinds of trends. We talked about electronegativity, atomic radius. We even mentioned reactivity, and even something a bit more subtle like density. So there's quite a few trends there. And again, Mendeleev kind of knew some things, didn't know some others. He didn't know the causation as to why elements in the same column acted the same way. And this is the answer. The first column of the periodic table has 1 valence electron. The second column has 2 valence electron. Skipping the transition metals and going straight to the main groups of this kind of 13th column, skipping from the 3rd to the 12th and going 1, 2, and then 13 to the other main groups, we have 3 valence electrons to the whole column. 4 in the next column, 5, 6, 7, and 8 in the last column, with the exception of helium, which only has 2. And so helium sometimes could be drawn in that second column, but because it is a noble gas, we put in the last column. It has its entire energy level filled up, which is what noble gases have, which is what that last column does for us. And so all of these dots, these are valence electrons. Why dots? Because that's the easiest thing to draw is a dot. So we use dots to show off valence electrons. Notice there's no more than 8 ever. Notice they're kind of relatively scattered. They, for the most part, exist in kind of like 4 different regions around the letters. Different teachers have different preferences, and even the different situation causes for different reasons for kind of splitting up the electrons as much as possible, keeping them together. So please don't be too worried about that. Right now, we really just want to show off that those valence electrons are there, and all of the elements on the periodic table, particularly the main group elements, the first 2 columns and the last 6 columns, have 2 valence electrons. And so now these electrons are important because they dictate not only chemical and physical properties they can kind of look up, but it's going to dictate how it reacts, which I guess is a chemical property. And so we're going to talk about not just the reactions, but the bonding. How will these elements bond with another element? And so we mentioned this before with terms like electronegativity. Nonmetals are going to take in electrons, and metals are going to lose those electrons because they don't have a good hold on their electrons. And so metals are going to give valence electrons to the nonmetals, or the nonmetals are going to bond to themselves. Nonmetals are trying to gain electrons, work their way up to 8, which is something we call the octet rule. And so when you have things like 4 and 4 can be 8, 5 and 5, they can share in just the right way, where it'll be 8 and 8. And we'll talk about that this unit. I do have a little bit of a thing here. So here's a nice animation between 2 atoms. Notice the valence electrons are coming together. The first energy level is I guess missing. This is just showing the second energy level. You can actually count those valence electrons. And when you count those valence electrons on each of them before bonding, even though it's spinning, kind of slow it down a bit, you can see there's 7 valence electrons there. And so 7 valence electrons, that is the second to last column. We call those halogens. And they're going to come together and form that bond. And they're going to form what's called a diatomic molecule, something we'll talk about later in this unit. Diatomic. Di meaning the number 2, atomic meaning atom. So we have diatomic atoms here. 2 atoms bonding together to form a diatomic molecule. Molecules are made up of atoms. So you have the formation of a diatomic molecule here. And again, it's all about the valence electrons, and they're going to be sharing their valence electrons. And so here we have a metal in sodium being in the first column, alkali metal. Here we have a halogen, second to last column, a non-metal. And this is where this one little valence electron here is going to be able to leave and be transferred over. Let's see if I can get my pen working. This one valence electron in the very relatively big sodium atom is going to lose it, and chlorine, with its high electronegativity, is going to take that electron in there. Sodium loses an energy level, chlorine fills up its energy level. And again, that's called octet rule, because you can count up 1, 2, 3, 4, 5, 6, 7, 8. 8 is great. We're going to say that quite a few times in this unit. And you can do that for both of these atoms when you're counting the valence electrons. That's what's on the outside. So we have 1, which is the new one, and then 2, 3, 4, 5, 6, 7, 8. That was, you had 7 pre-existing for chlorine, 1 more came in from sodium, and now you have 8 and 8, and now you have 2 ions that are going to be attracted to each other because they have opposite charges, and opposites attract. And so in summary, we have this slide here. We have 2 different types of bonding. We're going to talk about this unit. There's kind of a few more types of bondings out there, metallic being one of those. But for now, we're going to be talking about these 2, molecular and ionic. The molecular is sharing it. So we have nonmetals sharing electrons to add their way up to satisfying the octet rule. And back early in the year, we did naming, so you can actually name things. So 2 hydrogens and 1 oxygen is dihydrogen monoxide, and obviously the street name for that is water. And then the other type of bonding is transferring electrons. We're still dealing with valence electrons, but instead of sharing their valence electrons to work themselves up to filling up their energy levels, we're going to transfer. So in this case, magnesium is losing their valence electrons, its valence electrons, which has 2. You can see the 2 red ones. They're going to lose those 2 and give them to another non-metal, in this case chlorine. And back when we did our crisscrossing, we saw that magnesium has a 2+ charge, and chloride has a -1 charge. And so you needed 2 chlorines when we did our crisscrossing, 2 chlorines for every 1 magnesium. And again, you can see the electrons are leaving magnesium and taking up space over there in the chlorine. And again, you're going to have 8 valence electrons for the magnesium, 8 valence electrons for the chlorine, 8 valence electrons for the oxygen. And notice hydrogen only gets 2. Again, that makes a little bit of sense. Hydrogen tends to break its rules or has its own rules. Hydrogen is just trying to get to the end of its own row, which is the number 2, helium, 2 valence electrons. So hydrogen is fine for 2, but oxygen, magnesium, and chlorine, they're all going after 8 valence electrons. So that's our introduction into bonding. Thank you so much for your time, and remember, chemistry is everywhere.